If you've been watching this channel for a while, you may recall me bringing up custom villagers that you can design yourself and insert into the Japanese exclusive E+ version of the original Animal Crossing. As a brief recap, this works because Doubutsu no Mori E+ was compatible with various villager e-reader cards, which allowed you to scan a card on a connected Game Boy Advance and permanently move that villager into your town. To handle this technically, the game always reserves space on your save file in order to append villager information swiped in by an e-reader card. This means that all of a villager's information, from their name and catchphrase to their model and textures, is stored as data embedded within the e-card itself. And yes, the game will accept whatever information is swiped in so long as it's formatted properly. Several years ago, our friend Cuyler took advantage of this and actually made a tool to format custom villager data, which can then be appended to an E+ save file by using save editors. However, theoretically, you should be able to embed custom villager data onto an e-reader Dotcode and have this data scanned properly without a save editor. So, let's take a look at the e-reader one last time, and finally unlock the ability to print fully custom DLC villagers to import in a vanilla copy of the game. Before I can start on this project, there's just one little problem. This feature is only available in the Japanese E+ version of Animal Crossing, and I do not have a Japanese e-reader. Even though the Game Boy Advance itself is not region locked, the BIOS that comes included with each e-reader is. If you attempt to use the North American e-reader within E+, you will unfortunately get an error saying that the game could not properly connect to the GBA. So, in order to scan e-reader cards into this game, you will need to procure the Japanese E+ version of the e-reader. Also, the data within the Dotcodes differs slightly between regions, which means I need to sit down, research, and experiment with the various Japanese cards to see exactly how these should be formatted. So, I ordered a Japanese e-reader, and while I wait for it to arrive, it's time to lock in and figure out how exactly all of this data works. Before we do that though, if I'm going to be printing off e-reader cards and experimenting with the actual console game, I'm in dire need of a space upgrade. So I'd like to thank FlexiSpot for sponsoring, and they actually sent me a brand new desk for this video. The FlexiSpot E7 Plus is an ergonomic standing desk and was the perfect upgrade for someone like me. Not only does this desk give me the much needed space to work on projects, but the desktop is also perfect for attaching microphones and lights for my setup. Further, as a standing desk, you can easily adjust the height with the attached keypad, and I can finally stop hindering my health by sitting all the time. I was a bit afraid that an adjustable desk like this would be wobbly or insecure, but this desk is honestly one of the most stable I've ever used. Supporting up to 540 pounds, you can see how stable this desk is, even when adjusting the height. The keypad also comes with a USB port to easily charge something like a phone or a headset, which has been super convenient. Outside of desks, FlexiSpot also provides all kinds of products to upgrade your workspace and your health, including top-notch ergonomic chairs and appliances like air purifiers. If you're in the market for a new desk like the E7 Plus, you can take advantage of FlexiSpot's Black Friday promotions and use code YTE7P50 to get an extra $50 off the E7 Plus standing desk. And thank you again to FlexiSpot for sponsoring this video. I truly appreciate the upgrade here and the support. Now, let's finally take a look at creating our own custom Japanese E+ card. Just like my previous ventures, the best starting place for research will always be to look at the official implementation of an e-reader card. Luckily, E+ has over 80 villager cards that are all preserved online, so looking at the data implementation is relatively easy. From looking at these cards, it became clear that, just like their American counterparts, every E+ card is exactly 2,112 bytes. However, for E+ specifically, this data is split into 5 sections. The header here is 48 bytes long, and thankfully is universal across all e-reader cards. This means the research I did over 1 year ago came back in handy to format the header's various checksums. Note that if any of these checksums fail, the e-reader will spit back. Read error. So it's important to keep this information in mind, and we'll be revisiting this header later. After the header comes the card's title data, which is composed of two 33-byte chunks that simply convey the title of the card. Depending on the card's region, the data here is encoded differently. For North American and Australian cards, this data is normally encoded in standard ASCII. But for Japanese cards, like for E+ here, The title data is encoded in Shift JIS to represent Japanese characters. For our purposes, the title data here is always just the name of the game for both blocks. The next chunk of data is card specific and controls the contents of the letter that arrives in the mail when you scan the card at the post office. Just like we've done on the North American versions, you can set this data to say basically whatever you want. Really, the only difference here is that this data is encoded in E+'s custom hiragana character set, making it difficult to read in a standalone hex editor. Still, as long as we understand the character mappings, writing a simple Python script is easy enough to convert any text we want into its proper encoded bytes. After the letter data comes unused GBA minigame statistics. For the unfamiliar, there were several Animal Crossing themed minigames released on e-reader cards that required you to swipe additional villager cards in order to play. I've covered all of these minigames before, but just for an example, the relay race game requires you to swipe 3 villager cards, and the game combines their speed stats to determine whether you win or lose. The only issue is that the E+ cards are not compatible with these minigames, meaning the data relating to villager statistics is superfluous and can be set to anything you want. The final chunk of data here is the real meat of this video, and holds all of a villager's attributes and textures to transfer into the game. And when I say all, I really mean all, since everything, from a villager's name, gender, and catchphrase to their in-game model and textures, are controlled with this data. Since this data can be quite extensive, it is compressed through Nintendo's Yaz0 format, and requires a pretty close look to understand properly. Luckily, Cuyler's efforts on his aforementioned villager creator tool does a lot of the preliminary work for us, and documents nearly all of this data. From this, I found it's easy enough to just insert things like a villager's name or catchphrase since they are always found at the same offset. But most of the data here comes in the form of custom textures, which are handled a bit differently. Every villager texture references a color palette, which is stored here as an array in the RGB5 A3 image format. The max size of this array is 16, meaning a villager's textures can, at maximum, include 16 different colors. The remaining texture data is then delimited based on the model selected, and each byte's upper and lower nibble reference the index of the palette to control each pixel's color in a texture. To put this in simpler terms and to give you an example, if I have a palette with these colors and I choose a cat as my villager model, the next 256 bytes control the colors of the cat's 32x16 face texture. In this fashion, every byte controls 2 pixels at a time through their upper and lower nibbles. So if my first byte of data is hexadecimal 11, the first 2 pixels in this texture are mapped to the corresponding palette index color. Every single byte is mapped this way, and if we arrange them properly while you squint your eyes, you can see that these bytes kind of line up like a paint by numbers. This approach continues for every texture associated with a villager, and you can freely modify all of these to your liking. For my purposes, I chose a penguin and designed custom textures based off Piplup from Pokemon. I'm not too great at pixel art or textures, so I chose Piplup because the penguin model already exists in the game and it seemed the easiest to design. Anyways, Doubutsu no Mori E+ also has 3 Game Boy Advance minigames that are playable by connecting your GBA at the wishing well. These games are pretty cool and feature your town's villagers in cute little sprite formats, which means that every villager in E+ has a respective GBA sprite. So naturally, if you're moving in a villager with an e-reader card, they also need a GBA sprite associated with them. This data is also embedded in the card and is modifiable in a similar manner, but is actually an entire sprite sheet for the villager's head at different angles and with different expressions. This sprite sheet is 256 by 16 pixels, so we need another palette and an additional 2048 bytes to represent this sheet in our data. And that about covers all of the villager data here. So, I created my Piplup penguin villager with a custom name, catchphrase, house, and clothes, imported my Piplup textures, and saved this data as a compressed Yaz0 file. Still, you cannot just slap this onto an e-reader card and call it a day. Since all of our data is now customized, we have to format the header's checksums and finally put everything together. In essence, the header has 4 checksums that are all calculated differently. The data checksum is calculated as the 2-byte complement of the sum of all half words outside of the header. If none of those words made sense to you, we simply chunk all of the data outside of the header into 2-byte segments, sum them together, and flip the bits of the resulting number to get our checksum. 1 down, 3 to go. The size info checksum is a bit special because this is actually a 32-bit binary number where bits 9 through 24 convert to the size of all data outside of the header and title sections plus 2. This quickly conveys how large in bytes our actual data is, and makes a bit more sense when working with actual GBA games that launch through the e-reader. The header checksum is arguably the easiest and simply takes the bitwise exclusive of all individual hex values at these offsets in the header. Unfortunately, our last checksum is not so easy. The global checksum is calculated by delimiting all of the data outside of the header into 48-byte chunks. For each chunk, we take the bitwise exclusive of all of their bytes together and sum the results. We then add this result to the sum of all previous bytes in the header. Finally, we take the single byte complement of this value, and this is our global checksum. With that, all of the header checksums are accounted for, and we can now put all of this data together and make a working e-reader card. Before we get to testing, if you'd like to see further technical details or see my explanations written down neatly, I took some time to write extensive documentation for the E+ cards. This is posted right now on my blog site, which I previously haven't updated since... oops. Regardless, I'll include the link to this documentation in the description for anyone who might find it useful. Now, with everything formatted properly, I confirm that my Piplup card actually scanned on emulator, and it was finally time to convert this data into a printable Dotcode. Luckily, I've gone through this process before, and even made a custom wrapper tool to streamline the process of creating a Dotcode image. So I put all the data together and printed my first test strip. And thankfully, my Japanese e-reader just arrived in the mail. So, I booted up Doubutsu no Mori E+, plugged in my e-reader, and connected my GBA to my console. After going to the wishing well and downloading the custom software to the GBA, it was time to finally scan my card. And it actually worked. With a successful scan on my first try, all that was left to do was wait a couple in-game days for the villager to move in. Setting our clock 3 days forward and loading into our town reveals a brand new house on our map. And if we head over there, we can find Piplup waiting for us as a new resident. With that, we have successfully created a working e-reader card that introduces a fully custom DLC villager into the game, all on a vanilla console. And now that this works, we can also add some flair to the physical card by giving it a custom design and printing it on glossy cardstock. And I'd say it looks pretty cool. If you're curious on doing this yourself, right now you have to have some decent knowledge on how e-reader cards work and combine the outputs of several different applications. I plan to streamline this process by updating my own e-reader card creator app in the future, and this updated version will include a more in-depth texture editor, including the GBA sprites, a model previewer, and the ability to create an optimized Dotcode image straight from the app. However, I have about 5 other projects that I need to complete before I make this a priority, so this likely won't be completed for at least a few months. If you'd like to try your hand at making an E+ card immediately, I did do my best to document the technical process, so you can check out my website if you're curious. Regardless, I'd like to thank you all for being patient while I worked on this video. As always, thank you to Cuyler for assisting and providing additional documentation. And thanks again to FlexiSpot for sponsoring this video and project. I encourage you all to take advantage of their Black Friday deals to get discounts on new desks and find home appliances for as low as $79.99. Finally, thank you to my Patreon and YouTube members for their financial support who also helped fund this project. Special shout out to Lunascape, Cynthia, Dylan Trudeau, Silly Marina, Villager, Tarumi, Vinny Diddy, Pidge01, Kai D, ComfyBoy404, Cass, Hornet, Japan Eat, Tammy's Head, Exploding Bears, Holly Molly, Idrin, Sitz, Zip, Bobby Nard, Comfy, Tenchi Prime, Goose Fart, Moggery, Puff, The Casual Perry, Bubbington, and Cray for being my highest tier supporters. I hope you all look forward to future videos and projects like this. So, until next time.